Good afternoon, all. Kick things off slowly. Still a few people joining as we go, but rather than you all waiting here eager, I'll start to introduce today just before we kick things off. So first of all, just a big warm welcome and thank you for joining us on what is the next in the series of webinars we've been delivering throughout this year. Just going to pull my notes up so I don't miss anything. A couple of familiar names, definitely a couple of familiar names for people I work with, so no pressure there from me. So I'm just going to do a bit of an introduction for the day and then kind of hand straight into our expert speakers. So quite excited about this topic. It's something I've been working around for quite a while, or definitely a topic I've been interested in, so really excited for what goes now for the next hour. So thank you for joining us on high-fibre-count cable deployment. I'm joined by experts from both Viavi and Corning. I'll do some proper introductions shortly, but yeah, some really interesting perspectives and experience we'll be sharing throughout this webinar. So the format for this afternoon, once I've handed over to our speakers, we'll hear from each of them. We've just got a short presentation prepared just to cover off some of the kind of key areas and topics. But the majority of today is around the kind of live panel Q&A session that shortly follows that. This will be your opportunity to ask any pressing, burning questions that you've got on the topic of high-fibre-count cables and testing. So we'll hear first of all from them, and then I'll facilitate that session as the kind of second half of this. I've queued up a few questions already that we've had sent in as part of registrations and a couple that I've plucked off my head. But what I will do is recommend that each and all of you, this is your opportunity to kind of gain that insight and find out from the experts themselves any pressing questions that impacts you. Just going to drop into some housekeeping before we get into the fun part. So just a couple of recommendations kind of to get the most out of the webinar. So first of all, the best view in Zoom. You'll notice on your screens there's an option. In fact, I will stop sharing my screen briefly. Let me just get rid of that. Stop sharing. Cool. Now let's do this properly. So yeah, just a few recommendations just to get the most from today. So the first of all, in the should be top right corner, you'll see an option for view. There's two views you'll see in there, the speaker and gallery. When we're going through the presentations, the best view you'll find will be the speaker view. That will give you a full screen view of the presentation and the speaker at the time. When we drop into the Q&A and the panel session kind of post, we'll kind of flip back into gallery view. It should do it automatically, but you can also choose that option if you need to. And that will just allow you to kind of see everyone on screen. So first recommendation, just to have a little play around with the view so you can find one that suits you. Panel session and kind of throughout, what we'll be asking for is obviously as you hear from the speakers, you don't need to queue your questions up, get firing them into me as we go. I'll be moderating questions into our panel today on your behalf. So a couple of ways you can submit them questions. I've obviously spoke about the few that have come in already. But if you use either the chat function, and if you do use the chat function, just make sure you address your chat to the panelists, and that will find its way to us. What I'll do is I'll queue them up and I'll pose them to the panel kind of post the presentations. The other option is there's Q&A functionality built into Zoom. So if you have a look wherever your kind of toolbar is for Zoom, whether it's at the bottom or top, you'll see both options. You'll see chat and Q&A. Either way you get them into us, I'll be monitoring those throughout the presentations, and then likewise when we get into the panel session. Feel free to ask anything. We've got some great perspectives, like I said, from both Corning and Viavi, to kind of put a few different views on each of the topics anyway. So by all means, ask away. No such thing as a silly question, I hope. Please don't prove me wrong. Cool. So nearly all from me. I'm just going to go through some introductions, and just so I don't kind of ruin their flow once they get into the presentations, I'm actually going to introduce all three speakers at the start. What I'll then do is hand over into our first speaker, and then they'll kind of go through the presentations. At that point, then we'll kind of come back through. So bear with me for this bit. I haven't memorized this part, so I'm going to read it off the screen briefly for this one. So introduction for our first speaker that you'll hear from today. So Roshene McCool. Roshene is a Senior Market and Technology Development Manager at Corning Optical Communications. Specialising in single mode fibre and the applications in which it's used. She provides technical and market insight for Corning's global fibre and cable product line management teams. Roshene has 30 years experience in engineering and optical communication systems and subsystems, including many years designing networks for advanced radio telescopes. Roshene has held project management and coordination level roles in diverse teams throughout her career. Roshene holds a master's degree in electrical and electronic engineering from the University of Nottingham, and is a chartered member of the Institute of Engineering and Technology, the IET. I don't know if you're a quick hi, Roshene, just so we see your face briefly, and then I'll move on to the other introductions.
Hey there, James.
Thank you, Roshene. Right. So once Charlene's finished, she'll be handing over the ball. Once Roshene's finished, she'll be handing over the ball to Charlene. So Charlene Roux, Senior Product Line Manager at Viavi Solutions, specialising in Otdr and fibre testing. She provides technical and market insight for Viavi's current and future fibre optic test solutions developments. Charlene has 15 years of experience in fibre optic test equipment. She is skilled at understanding customer needs and market opportunities, leading innovative products to success. Charlene holds 3 master's degrees in electrical and optical engineering from Telecom Saint Etienne, in entrepreneurship from the Institute of Business Administration, France, and in general management from Lyon Business School. Quick hi and show your face, Charlene, if possible. There you are.
Hello.
Charlene, thank you. Right, last but not least, so Charlene will then hand in to Tom, who will be our third speaker and the third panel member for today. So Tom Ronan, Regional Product Manager at Viavi Solutions. He brings over 20 years of experience in installation, testing, implementation, and business development of fibre optic solutions across the globe. Past roles included engineering contribution to fibre optic interconnectivity standards. He brings a wide experience supporting network operators and delivery partners to adopt new technologies and enable fibre deployments. This included devising more efficient and automated testing methodologies for acceptance, provisioning, and maintenance across network phases. Tom has a bachelor's in engineering in optoelectronic and laser engineering from the University of Hull. Quick hi and show your face, Tom. There you are.
Hi, James.
Thank you
Hi,
very much. Cool. So that's pretty much all from me at this moment. I'm going to shortly hand over into Roshene, who's going to spin up the presentation and take you through at least the first part. I'll obviously be monitoring questions and Q&A in the meantime, and you'll see my face again when it comes to the panel session. So thank you very much and enjoy.
Thanks, James. I'm going to share my screen now. Just let me know when you can see that.
I can see that. Thank you.
Great. So hello, everybody. As James said, my name is Roshene McCool. I'm a Senior Market and Technology Development Manager at Corning Optical Fibre and Cable. So today we're going to talk about enabling high fibre count cable deployment. And before we get there, I think we really need to ask the question, why do we need high fibre count cables? So we need high fibre count cables because we need more pathways. We need more fibre pathways to serve more connections. Why do we need that? Well, because we're seeing an increase in mobile subscribers, and whilst mobile networks may appear wireless, actually the core of those networks is very highly fibre connected. We're seeing an increase in subscribers in fibre to the home and fibre to the business. We're seeing more pathways required for Internet of Things devices that sit within our homes and within our cities. And finally, we need more fibre pathways for more data centre locations as we see the trend to data centre localisation increase, or at least continue. Not only do we need more pathways, but we need more capacity on those pathways. That capacity is only delivered by wide spectrum, low attenuation fibres that serve user bandwidth requirements. And again, Why do we need these large bandwidths? Well, as users, a lot more of us are working from home. We're using a lot more video. Video is a very bandwidth hungry application. And not only does it need bandwidth in the downstream direction, but video conferencing needs symmetrical bandwidth to be delivered effectively. And in addition to that, a lot of our applications, a lot of us are simply using more bandwidth in our homes. So these pathways and the capacity along those pathways is diffused, if you like, in many, many different locations. Now, in order to deploy these high fiber count cables, we need to efficiently use our infrastructure. That is to say, we need more and more fiber in the network, and the space in which to install that fiber does not expand with our requirements. It remains static, and that means we have to get more and more fibers into a smaller and smaller space. Now, at this point, I also want to sort of, if you like, get a little bit deeper into the definition of a high fiber count cable, because a high fiber count cable is a relative term. We don't just mean fiber counts of 1,728 or larger in a single cable. It may well be that 144 fibers is a very high fiber count if we're putting it in, say, an 8mm duct. And so what we're really talking about here is the high density of fiber in the cable, because what we really want to do is get as much fiber into our smaller space as we possibly can. And of course, we want to do that quickly and efficiently, so we need efficient installation, and we need products that will speed up that time to install and reduce installation error. So I've gone into, in some detail, the why we need this, and then we need to talk about the how. So we're really talking about high fiber in cable density. That might be in very large cables with very, very high fiber counts, but it can also be in much smaller cables at relatively low fiber counts, but at very high densities. Now, achieving this is quite an engineering feat. There's quite a lot of engineering that goes into making a high density cable which will perform optically in the network. And what we need for these high density cables is these advanced optical fibers. And the features of these advanced optical fibers are fibers that have a broad spectrum, that have low attenuation, and that broad spectrum low attenuation is protected by bend resilience. And also that these fibers have a low outer diameter, because if we can miniaturize the fiber, we can miniaturize the cable. So let's now think about this efficient use of infrastructure and how these cables are used in using the infrastructure efficiently. Well, the very highly dense microcables use microduct, and that microduct can use that duct space really effectively, because the microducts come in bundles that allow you to install on day one, but equally allow for the provision of space within the duct for future upgrades as the network grows. We can use microduct for overrides. So if there's a cable that already exists in a duct and it's not possible to put a traditional cable over the top of it, we can run a microduct and put one of these very highly dense cables in there to use that infrastructure more efficiently. And it all comes down to the density of fiber in cable. And that's about the cable design, the arrangements of fibers within that cable, and the advanced optical fibers that are used within those cables. Of course, efficient installation is going to allow us to get these fibers in the ground quickly. And in order to do that, then really what we're looking for is a suite of features that make that installation faster and easier. So smaller, lighter cables, but with the same fiber count as we expect in our networks. Fast access to the cable so that we can quickly get access either at mid-span in order to joint, or potentially if we need to repair that cable. Fast jetting, so a lot of these micro cables in micro ducts allow you to blow the cable through that duct, which increases the speed of installation. And then of course, resiliency in handling. So now we start to get to some of the fiber features. If we have bend resilient fibers in those cables, then we can have resilience in handling. If those fibers have mode field diameters that are compatible, then we get splicing efficiency and test acceptance efficiency as well. And if we've got low OD fibers, then we can get that density of fiber in cable. And of course, depending on how the fibers are arranged, if those fibers are arranged in a ribbon format, we can use mass fusion splicing, which is a faster way of splicing more fibers simultaneously. Now, I've just mentioned the term mode field diameter. So I want to just talk a little bit about what mode field diameter is, because it's important for the topic that we're talking about today, which is, of course, the ability to efficiently install these high fiber count cables. So in an optical fiber, the light is confined to a high index region of the fiber, and that is called the mode field diameter. So the mode field diameter is where the light is traveling in the fiber. Most fibers installed in legacy networks have a 9.2 micron mode field diameter that sits within a range of plus or minus 0.4 microns from that nominal center of 9.2 microns mode field diameter. Now, why does that matter? Well, it matters particularly on splice and test, because if we splice together two fibers that have two different mode field diameters, then we test it with a single unidirectional Otdr measurement, then you get these either an exaggerated loss or an exaggerated gain. And that exaggerated loss or exaggerated gain is associated with the reflectance that's happening and the scattering that's happening at two fibers which have two different mode field diameters. Recall, the mode field diameters is the part of the fiber where the light travels. So if one is smaller, then you're effectively putting light traveling in a wider band into a fiber where the light is traveling in a smaller band. In reality, the splice itself is sort of the average of these two, and that is the reason why bidirectional Otdr testing is recommended in links. If we're short of time, if we need to do this quickly and we're looking at unidirectional Otdr traces, then this effect can create an awful lot of ambiguity on test. And what that ambiguity does is it adds delay and it adds extra cost into the installation of the network. Now, of course, as you would expect from Corning, we have a whole suite of products enabling efficient high fiber count cable deployment. That includes our rocket ribbon extreme density cables, which have very, very high fiber count in a single package. The fibers are matrix ribboned, and that means that they can be used in mass fusion splicing for very fast delivery of spliced networks. We also have micro cables, our mini extend cable with binderless fast access technology, which allows you to access that cable very quickly. They can be jetted into microducts for fast and efficient delivery, and they are some of our most dense fibre and cable solutions. And of course, those cables are enabled by advanced fibers. Both of those cables come in our SMF28 Ultra fiber, which is low loss, has a compatible mode field diameter of 9.2 microns. It has a bend resiliency associated with G657A1. In fact, it performs better than that standard. And also our brand new SMF28 contour fiber, which is a first of its kind combination of a compatible 9.2 micron mode field diameter, G657A2 bend resilience, and also an industry leading low loss. So James, I'm going to pass this back to the team now for Charlene, I believe.
Can see that okay.
Sorry, is it full screen?
Yep, that looks fine.
Okay, perfect. Thanks. Thank you, Roshene. Very good topic about cables and efficiency of deploying those cables. We know that with fiber testing comes other challenges as well. And we want to discuss those challenges and how to overcome them. So the test challenges that currently happens with dozens of fibers is obviously quite exponential when you go to thousands of fibers, because the number of tests that you have to do is way more. The number of test results, reports that you have to do is way more, and also the overall management of the workforce and the ability to have qualified and trained technicians is also one of the challenges that's currently happening, and especially important when you deal with higher fiber count cables. So Viavi has quite few solutions, but first I would like to just restate everything that could happen on a network, on a fiber link, or fiber path. There are multiple faults during installations that we need to take care of, and being able to test them properly to avoid site revisits or excessive repair costs later on. So connector inspections is for sure one of our key message. Always inspect before you connect. This is still the major faults that's happening in the field, right? Anytime you have a connectors, make sure this connector is properly cleaned and that you have inspected it, that it's cleaned. We see a lot of macro bending as well, even though there's been resilience fiber, we still see some standard fiber being, smashed in the door of a cabinet or bent into a extreme radius, which create, of course, significant loss, especially at the wavelength that's used for transmission. Roshene talked about mismatch of fibers. I have a slide also talking about that just after that, but it's pretty important, especially as we go deeper and deeper into the network. We see legacy fibers spliced to new fibers, and that's a phenomenon that we see with those installs. And then other things like continuity testing, mismatch, cross connections. This happens a lot as well as we go into point to multi-point type of access as well. So Roshene talked about the difference in mode field diameter. This is exactly what you would see if you do unidirectional tests with an Otdr. So if you test different a fiber with different sections, and those sections have different type of fiber, you will see that, as an example, from A to B, we would see what we call a gainer. So I call that a false positive because the gainer is not identified as a fault, it's identified as something positive, so potentially right, but we don't really know. And when we test in the other direction from B to A, we can clearly see that we have an exaggerated loss, so a false negative, I call it too, because if you only test in that direction, you think, so you fail, you reach the thresholds, you fail, you're going to fix it, you're going to try to resplice it, but you're going to fail again. The only way you can make sure that the value that's measured is the true loss value is to do a bidirectional analysis. So what we do, we take the loss from A to B for this specific event. We take the loss from B to A and we average it. So we divide by 2. And at the end, as you can see on this example, something that failed in one direction is actually a pass overall. So it's way below the standard threshold, which is typically 0.1, 0.2 dB. So it's really important in order to gain time to do not have those ambiguous or guess about what's the true results, to do the best practices with bidirectional Otdr testing. So when we look at all the folds, everything we need to care and test with those high fiber count, we have to use a different process because the current process doesn't work. It's too complex, it's too manual. So we need a more automated process, or what I call a leaner process, against what the traditional manual process. So we can see here a typical link between RDF. So everything has been installed, spliced, and then you want to commission the link. You can use a device which has an all-in-one test solutions, which can do loss and an Otdr. And you plug them through a Mpo switch, optical switch that can connect to 12 fibers. When you do that, the system will automatically sequence the measurements, IL, ORL, and Otdr bidirectionally, because it will dialogue with foreign units, and you will be able to have a complete report of your cables in a timely manner. The automation comes from the fact that the switch is automatically sequencing 12 fibers, so it can be typically for a ribbon fiber. And also it will allow you to have time to prepare for the next 12, meaning inspect, clean, make sure that the test ports is actually in a good shape to do the measurements. So overall, by doing this, if we take an example on 576 fibers, using such a linear process will actually divide test time by 2. And the more you add up test functionalities such as bidirectional loss or bidirectional ORL, of course, we will even improve more the overall testing time. And everything, of course, is guided. So you just have to follow the steps one by one. It's fully controlled. The test setup is fully controlled, and it's easy and a simplified process. So when you have all your test measurement done, you have optimized the testing, you need to optimize the way you do your reporting, and you send back your test results to the instruments, to the manager or to the client. So we can see here on the table on the bottom that if we take 576 fibers again, 3 wavelengths, so 1310, 1550, 1625, that's recommended now for for now and future applications. You have one file for IL/ORL for 3 wavelengths. And then for each direction of bidirectional measurements, you actually have 2 times 3, so 6 files. All of that on total for the complete acceptance tests, it's 4,032 files to manage. So we can understand that it is quite difficult to analyze all of them. So the system that's been putting in place is that the test instruments will do the test and bring the test result into a cloud data management system called StrataSync. From this cloud data management system, we can extract directly test results and do KPIs and analytics on what passed, what failed, what reached thresholds, where and when. So everything is already outlined and well presented in order to have a clear view of what's happening in the field and in real time, because one person cannot read all 4,032 results. You need a more automated system that would provide you with a clear view and understanding of the test results and do some analytics on that as well. So overall, the test time improvement also comes from how you handle the overall workflow, getting the job information onto the instrument and getting back all the test results onto a system that can provide a preset of analysis for you. So that's the first field approach, I would say. I will let Tom, my colleague, talk about another approach.
Thanks, Charlene. If you can move to the next slide, please. So, Charlene explained very well on how we can drive more automation, more efficiency using field deployed instruments, right? Using a test set that is accompanying a field technician is deployed to the field. And during that acceptance test or that qualification characterization test, we get a picture in time of the network. Some operators are considering other ways of managing and driving automation in their processes, and looking at ways that they can use these test systems not only to take a picture in time during that network qualification phase, but also that it can be systems that can be used from construction across the installation or the activation phases and across maintenance cycles. To do this, we use what we call a rack-mounted optical test unit, optical test head. So this would be deployed in a central office or an exchange environment. And we are cabling up the test head through optical switches. So a bit like Charlene talked about on an instrument level, we're using high capacity, high count switching banks to automate the testing process. So we embed the test head, the test technology, Otdr, into the rack mount test unit, and then we cable that up to the fiber under test. And what we're doing then is we're loading these mass cable information or high fiber count cable information into a server software which does real-time online acceptance testing. So as you're building the network, whether it be section by section or end to end, you get a complete picture in real time of the network. And your splice, as you're maybe even doing splicing schedules, you're putting in new joints, you're using this system to automatically test the fiber and the quality of that joint installation. So we can do that with the field tech, which could have a mobile app. They're controlling the test unit, which could be sitting further back in the exchange environment, or could be even on a mobile case. And then they're creating a test campaign or a test routine to qualify the installation. So very useful when you've got already your permits pulled or your traffic redirected and you're in a splice joint, you're qualifying that fiber as you're building out those sections or as you're doing it end to end. So using it as an assistant to assist the technician that's building the network in a linear process. You enable a consistent lens into the network. So no matter if it's the technician deploying it or someone retesting it later, all of those control processes are in place and control acceptance limits are in place in automatic to ensure that everybody is qualifying to the same standards. And what we're doing is reducing overall workflow and steps in getting the data from instruments back into a software system, maybe doing some post-processing and then putting that data back into a cloud where an operator can review and accept or reject the cable installation performances. So what we're trying to do is mitigate or lower the amount of steps in getting those tests done and giving consistency between different work groups which would be involved in the cable infrastructure over the lifetime. Next slide, please, Charlene. So as we talked about, we're really self-documenting the network as we're building it. So we take all of these different steps within the process, from building, splicing, jointing your network, connecting it out within your ODF frames inside your central office or your exchanges. You're doing your test documentation, submit the test documentation, and then we talk about, okay, are those results accepted? Are they in line with the requirements of the network? Do I need to audit, repair, or fix? And even in the end, are all those fibers of the right quality? So what we're trying to do is collapse that into a more real-time automated process using an embedded test system, which helps to collapse some of those steps, making it more real-time, more automated, and ensuring better real-time success across the different cycles of the network and across different owners of the network in some circumstances. So we're reducing the overall labor hour and labor time to qualify the network. And again, just like Charlene pointed to on the instruments, we're using KPI and analytics to look at the worst splice, the unhealthy fibers, and the ones that need remedial or repair mop-up, and driving that in an overall closed loop process where we know who performed the measurement, what time, what installation, and you get real-time pictures of your network and as your performance, regardless of the life cycle, where it is in the life cycle. So just to wrap up on the slides here before we hand over for the more panel discussion. Again, like Charlene pointed out, we have a lot of benefit, as Roshene also mentioned, in deploying these high fiber count cable systems. There is some areas that we need to look at and to ensure the infrastructure quality, making sure we're doing the right time acceptance testing, making sure we're doing the right processes, but it's all the compromise between, okay, what tests we do, or how we speed up the installation process, and how do we get it done correctly and right the first time, so I'm not having huge costs in my operation and in maintenance or in mopping up poor quality installation from the get-go, because we want to ensure that infrastructure quality is in place, and we want to make sure the right compromises aren't being made, but also the right steps are being taken to ensure the network is ready for future-proof performance. And that is all about looking at policing or controlling the methods, controlling the process, and controlling the quality of the installation, and trying to drive more automation into those processes to make it easier, faster, and quicker to deliver these types of cable infrastructure, so that we are driving the right amount of steps into those processes. And then once the network is delivered, that we have the right systems and tools to automate the acceptance, to govern and drive KPI, so that we're only accepting and installing good quality network. And what we're doing is trying to ensure better quality networks better performance networks and healthier networks as they're being delivered. So I'll stop there. Thanks, James, and I'll hand it back to you.
Thank you, Tom, and thank you, Roshene and Charlene, before that. Thank you very much. We'll shift into the panel session now, so if you want to stop sharing, we'll get kind of videos back on screen and get you all kind of here and present. There we go. So like I said with the view before, just at the start of the call, if you flip now into gallery view, you should see everyone kind of in one screen. A couple of questions have kind of come in while we've been going through that. So we'll kind of start to work through some of these and get our expert panel's kind of opinions and perspective on these. I think it's quite a good mix, definitely covering cable testing and some of the processes as well. So quite interested to see each of your kind of perspectives, point of view. Get Charlene, I don't know if you can share, come back on video wise, just so we've got the crew back together. There we go. Cool. Cool. So thank you very much. Just call out to the audience. I've seen a few questions coming through from Q&A and also in the chat. So if you've had any questions, whether it's about anything that's been shared and you just want to dive into in a little bit more detail, or maybe get a few different perspectives over something that was shared just during them presentations, then by all means use the Q&A or the chat. Just make sure you direct it to the panelists. And we'll get them asked for you. So yeah, I'm going to kick off with an easy question. I'm actually going to direct this to all of you. So just to kick things off and warm you up nicely, in the last 3 to 5 years, if you had to call out one thing as the best or biggest advancement we've made to enable kind of high count fiber, what would it be from each of you? So I'll let you jump in any order, but just interested in your biggest advancement you've seen in the last 3 to 5 years.
Shall I start? So for me, and it probably won't be surprising to hear that I think the most exciting thing from a perspective of the fibre and cable is the recent launch of SMF28 Contour. Because that fibre has a combination of features that mean that it can be used in high fibre counts, it can be used in high density, and it is efficient in installation. So, you know, the bend resilience, the fact that it has a 190 micron option, which allows us to miniaturize the cable, and that it's low attenuation, compatible with others, with fibre that's already in the network. But I think more generally, it's the low OD fibres. When it comes to this topic, we can't really get really high density in cable unless we're prepared to go for low OD fibre.
Awesome, thank you. Tom, Charlene, on to you.
Yeah, from my perspective, and you know, it's opened up a lot, is obviously the OD of the fiber and the convergence. So Roshene talked about the convergence in the network, what's happening out there on the endpoints, and of course, more pathways required. And it's how do we do to collapse those pathways? What do we do to try and save space inside of the exchanges? We see a lot of adoption of Mpo in central offices as they try to prepare themselves for dark fiber services, maybe to cloud operators or for their own products. And the whole connectivity shift that's happening from your classic simplex fibers, simplex interfaces inside the exchanges to Mpo. And so that change has actually shifted the way we think a lot about the way we test those networks. So rather than going fiber by fiber by fiber by fiber, and then coming back and going fiber by fiber with insertion loss tester, and then through with the Otdr testing, and then trying to talk to someone on the remote end, is collapsing the steps in the tools that's used and making that more efficient. So bringing switching into instruments, switching into rack-mounted remote test units to enable faster, easier testing and open that up to simplified installation process, so not making that complex. I think over the last 2 years, I would say that's a lot of the big advances and shifts I've seen changing in this area to accommodate that. As Roshene said, accommodation on the outside plant, but how do we accommodate all those termination points inside of the head end or the exchange, you know?
Thank you. Charlene?
Yes, so just to complete what Tom says, I think with all those challenges that we've seen, what for me has been the most advanced is how well our devices are connected and how well they can be included in a cloud system, and how well we can, get hold those thousands of test results in less than a minute onto a database where someone has true visibility of what's happening in the field. For me, that's key and really great progress within the test instrument industry.
I seen that slide with just the 4,000 tests and thinking manually having to look through them and see pass fail kind of stuff. Having a dashboard that does that for me looks like an absolute game changer from past experience. Cool, thank you very much. We've had a few coming in, so I'll kind of drop into a few of the audience questions now, and we'll bounce around a few different topics. So one from the chat, and I'll open this up, so by all means jump in. Do you think ribbonizing is best practice when considering fiber splicing now? Is it worth the investment needed in training, tooling and test equipment, and what return can be expected?
Yeah, I can start if you'd like, James. Well, of course, fiber can be purchased within cable in a ribbonized format already. And so in a question like this, it really, networks are not simple environments, and each location in the network is going to be quite different. So what I would say is very simple. If I wanted to answer this question simplistically, I would say ribbonizing is not necessary in the network if you are already purchasing ribboned fiber. That's the first thing. What does ribbon fiber give you? Well, it gives you the means to mass fusion splice. And mass fusion splicing is certainly faster. If we think about the difference between single splicing and mass fusion splicing, effectively in a mass fusion splicer, you're doing 12 fibers at once. In a mass fusion splice environment, the mode field diameter really starts to matter, because in mass fusion splicing, lateral alignment can have a big effect. So the lateral alignment of the fibers within the splicer really matters. And if there is any lateral misalignment in the presence of mode field diameter mismatch, that means the splice loss will be greater. So I would say, yes, it's worth it if you want to use mass fusion splicing and speed up testing. Of course, not everybody has an existing legacy plant that's already ribbonized, and so that's where if a carrier wants to use mass ribbon splicing throughout, then the ribbonizing does start to become something that you might want to use. It really makes a difference in the extremely high fiber count cables, so 1,728. We have cables, and I was trying to talk about this. When we're talking about high fiber count cables, we're also talking about relatively small cables going into really tiny places. And there it may not have the returns to do the mass fusion splicing in comparison to single fiber splice, because the fiber counts are not as high. So so thank you.
I think to add to that as well, Roshene, what was the question was, the investment needed and the training needed. I remember when just single core fusion splicers were seen as a fear factor. And everybody's like, oh, we don't know if we can get all these technicians to go out there and do this well and do this with good quality. You know, the mass fusion splicers vendors have came a long way in simplifying the way you strip that fiber, you cleave that fiber to get better alignment on that fiber. And again, it's around best practices, it's around hygiene, it's around keeping the alignment chucks clean and following the vendor recommendation. And in time, that investment will pay back, because the payback is, of course, getting more fiber out there, which means that you've got more product, you've got more footprint to network, and you're driving a lot more revenue in a faster time frame. So we're not talking about cutting, you know, a couple of hours off here. We're talking about cutting days and days and days off testing. You know, we've got some customers talking about taking 3, 4, 5 weeks to test the network. That's before we even consider mopping up the failures within the network, right? And the failures within those splices, because one thing that needs to be considered is getting the testing regime tightly controlled in alignment with your deployment processes, and getting control on those mode field diameters to ensure that when you are doing acceptance, that you get it right the first time. Because if you do have to go back and resplice, and you're doing that because it's a mismatch in mode field diameter and you don't know about that, then you're not only resplicing 1, you're resplicing 12. So every resplice you're doing, you have to reply that by in number of 12, which means you're retesting more the network. So it's all about getting your practices right. And if you can get those to line up well and get those controlled in accordance with your delivery processes, the ROI is there in terms of getting that network deployed faster and easier.
Thank you. Cool.
James, can I just add something to that, which is that if you have routes which are extremely high value routes, where you have a lot of fiber in that route, and that route gets cut for whatever reason, then you know, the ability to repair that route at speed can be significantly improved if you are able to use mass fusion splicing.
Yeah, it's a good thought. I always thought the fault to one going through a cable, obviously the nightmare most of the time. No, interesting point. Cool. I've got a few more kind of questions just from the Q&A, so I'll go through these once again. Just feel free to jump in. First of all, what is the maximum number of fibers which can be tested in one batch? And that's in terms of most fibers kind of supported per MPO connection. Going to come to Tom or Charlene for this one. Test question. Did you get that?
Yeah, so typically on field instruments, we can go in, depending on which instruments we're talking about, and depending on the type of test, whether it's insertion loss or Otdr or both, we're typically running off 12 or 24 fibers on a field instrument. So that's predominantly where we stop. If we are talking about a deployed rack mount system, then it's the volume is huge, right? We have 1,000. We have some systems that can go up to even 4,000 cores from a single test head. But then you're obviously talking about banks and banks of splitters, switches, I should say. But field instruments is typically 12 or 24.
Awesome, thank you. Next one is, will the two testers sync with each other in case of a bidirectional test in order to ensure that the correct fiber in the MPO is selected on both ends?
I can reply to that. So yes, it will synchronize. So the two instruments will be connected on the same ribbon, for instance, and they will try to talk to each other. So they will try different ports in order to connect. Once it's connected, then they can exchange using a typical Ethernet protocol over the fiber. And they can exchange test data and settings, naming conventions, all of that. So everything is synchronized between both units.
Awesome, that answers that one nicely. A really great question, actually. I'm going to read this one out, so bear with me. So delivering infrastructural quality and acceptance testing appear to be the focus. In an environment where when path counts and data rates per path are increasing, is there also emerging demand for embedded monitoring that can guarantee service quality over lifetime? Are the tools needed the same, or are they different?
So I can take that one, James. So typically the tools can be used, field instruments can be used for managing those pathways over your lifetime of the network. So you have the field instruments that the installing build teams can use, your field instruments that the technicians in the maintenance cycles can use, but it comes to cost, time, and compromise, right? When we look at that, obviously, when we kit out a technician, we're at the mercy of the technician to find the fault, so we have a dispatch cost, right? And given the huge pressure we have in the industry now of having skilled labor, that luxury is not there to have hundreds, if not thousands of technicians running around looking for faults during those maintenance cycles. So that is why we're getting increased demand for centralized test systems to be rack mounted with the remote fiber test head to be installed and used for construction acceptance, and then being there to retest in case you need to retest for a specific client at certain wavelengths, or being there to alarm in case of the fault. So, you know, these systems can routine your cable infrastructure overnight or at set schedules, and they can be there constantly checking your network. It could be an environmental fault, so there may be you know, a flood that came through, storms, we get plenty of them here in the UK in different areas, and can cause infrastructure damage. So you can go and check automatically with these systems and then get an alarm where you have either an attenuation threshold alarm or a cutter and a vent alarm, which deviated from the original as-built or baseline measurement that was done. And then obviously those systems automatically trigger the technician to go out and show them and give them the distance to the fault. So that whole cycle of getting in the van, driving out there, plugging in and trying to figure out where the fault is gone. It's just going straight to site to fix, which takes a whole chunk of time off the repair schedule.
I would like to add something to that as well, which is that the wavelengths that are used in a lot of these inline sort of testing systems are the longer wavelengths, right? They're at 1625 nanometers. Those wavelengths are particularly impacted by macro bend. That is to say, if bends happen within the network, they're the wavelengths that will see the highest attenuation. And that is another reason to consider broad spectrum bend resilient fibers in the network, because if you are going to put automated test on there, you don't want to be seeing errors that are associated with a bend in the cable or in the fiber rather than an actual event.
Thank you. I'm just going to do a quick call out before we go into the next question. Obviously, conscious with hit time, we always plan these for kind of 60 minutes, and we plan a little overspill anyway, just in case we've got questions queued up, which we have got a few still. Conscious that we've all got diaries, so if you do need to drop off, by all means, thank you for joining. If there's any questions that you want to raise just before you do, you can watch the recordings back just for the answers, or we can get you kind of answers post. So if you are going to dash off, get your question in the chat, even if you're not here to listen to the answer live. You can obviously come back and watch. So, but yeah, if people do start dropping off, thank you for joining us. I will continue with a few more questions if that's all right. Just some good ones kind of lined up. So, cool, right. So, quick one, hopefully a nice straightforward one. Unidirectional or bidirectional? What do the standards recommend?
I take this one. So standard recommends IEC and TAS standards recommend bidirectional Otdr. Yes, as to get the true loss values. Also, that's a bit obvious, but if you do 2 measurements, the uncertainty is less. So always better.
So just to add to that, I think there is some misconceptions as well with unidirectional OTDR. So one of the most important things we need to make sure is obviously the overall attenuation of the link, but the continuity of the link. Is the network straight, right? Have I suffered somewhere through my splicing schedules a crossover and I've got a transposed network, something's wrong in my network? Typically, those cannot be mitigated with the unidirectional OTDR unless we're using a receive lead at the other end and we're actually checking that, making sure I can see my launch and my receive. So we can have all of these glorious unidirectional OTDR measurements, but it still doesn't mean that I don't have a mapping issue within my network. And that's why there is a recommendation to do bidirectional insertion loss, bidirectional ORL. So the standards stipulate that, you know, uni or bidirectional insertion loss is good. But ORL, which is another problem we have in the network, and can be induced into the network, is a measurement that's done from each end. So it's a bidirectional measurement in that fact, right? So one would consider, well, if I have my gear there and I'm doing those measurements in terms of overall process, it's better to do it all in one go.
Awesome, thank you. And leads quite nicely on. You've just called out a few of the tests. So there's another question that's come in. Should we only perform bidirectional testing with OTDR, or is insertion loss and optical return loss set testing also a requirement?
Yeah, so I think that's really mapped into what I was just saying, right? One other thing to consider is who's going to use the network in the end. Typically, if you talk to the planning people, they want to know the distances and they want to know the actual insertion loss of the link so that they know it can facilitate the services that we're going to deploy over the top. That's perfect if it's your network and your services and you know what you've planned for the next 10, 20 years on that network. But, you know, oftentimes we're delivering different types of services. You know, we're having dynamically changing network. We're having network function virtualization. We're having different types of services being put over the top. So what's right and wrong in terms of the right results to have? I think from a results perspective, it's better to have all of the above, right? So you've got the information regarding your insertion loss, you've got the information regarding your optical return loss at your various wavelengths, and you've got your OTDR measurements and your VINT information measurements to boot, so that you have all of that information there regarding if planning needed, if your repair teams needed it, and who needs it, who needs that type of data.
Thank you. And actually that leads quite nicely on. I think you've part answered the next question anyway, so I'll just kind of come back in case there's any other. Yeah, look at that, 2 in 1. So one of the other questions that was in, which I think you have just answered, but we'll just double check. So we provide, and this is a question coming, we provide dark fibers with the goal to sell a dark fiber product. We don't know the client service types. What would you recommend? So
that's exactly it. So that's one of the struggles with a dark fiber provider, where you're offering that product to X client, right? And those clients can come from a whole varied industries, can come from mobility, wireless market, they can come from cloud market, they can come from private businesses, and they're buying that dark fiber from you. In the end, most of them will come with the requirement of what they want from in terms of measurements to accept that dark fiber and to have cross agreed SLAs in terms of how that fiber would be managed. In that instance, you need to consider the operational cost. So what I mean by operational cost is, okay, I've built the network and I've gone very quick because I want to just do it very simple and I'm just going to do unidirectional OTDR. And then every time a new client comes in, they go, well, I need the insertion loss results. Another one comes, I need the ORL results. And someone else goes, well, I need to see your per joint splice loss result. And the answer is that's changing depending on who offering the network to. So it means you're going to have to go out as you offer those networks and retest all over again, which is doing a wholesale retesting of your network as you're offering those to the different clients. So the best path is to get that done right the first time, cut it in right the first time, have all your insertion loss, return loss, and all your bidirectional measurements from the get-go, and therefore you're able to handle an array or most 90% of the requirements that come from your clients, unless they start to ask for higher advanced testing like PMD and CD, which we're not covering here today.
Yeah, I would add to that as well, which is that the quality of the product comes from, you know, the ingredients that you use to make it and the thoroughness with which you adopt the correct processes, right? Right at the beginning, if it's uncertain what might go over these fibers, you really need something that is going to be future-proof, that has the broad spectrum that can accommodate all of the next generation transmission technologies, from, you know, the next generation pond systems to the symmetrical systems to coherent, you know. So you need something that's broad spectrum, that's going to perform well across the O, the O, the E, the C, the L, and, you know, all of the bands. You need a fiber that has bend resilience, so that bends do not create spikes in attenuation at, say, measurement wavelengths in this, or in the C and L transmission wavelength bands. You want a fiber that's going to be compatible, so that you don't have big return losses, you don't have mismatches in the network. And also, I would say that for networks like that, you really want to build as you grow. And so things like micro cables that can be jetted through microducts, where you can install a network with a series of microducts, install a high density cable, and then you still got ducts that don't require a dig to then build as you grow, as that network gets bigger. So I would say it's about, as Tom said, it's about doing it right the first time, but it's also about what products are you using in that network, and are they quality products that are going to future-proof you?
Thank you. Right, I'm going to fly into Q&A now. There's a few banked up, so I'll fire these ones out. So first one from Q&A, can we have bidirectional OTDR tests using the Rackmount systems?
Today, no. So that is the Rackmount systems today that we are deploying are using a single-ended system. They're widely used in PON network deployments, where we're using them to qualify the feeder within the access and then the distribution and the activation stages. That's not something that is available today, but it's stuff that's being explored for future iterations.
Thank you. All right, so that's one. So this one's a two-part question, so I'll ask the first part and then follow up straight away with the second one. What type of OTDR can support MPO tier 2 testing, single mode and multi-mode, modular type, and most cost effective, sorry, so recommendation.
I'll take this one, I think. So for multi-mode and single mode, there are quads OTDR, we call them. So that's 2-port OTDR, 1 port for multi-mode, 1 port for single mode. Today we have MPO module switch, which is mainly single mode, but we can also add up an external MPO switch, which could be multi-mode. The external switch will be driven by the same software. So the same software operates with either the module or the external switch. Just the external switch is connected via a USB port.
Awesome,
That
thank you.
would be the right solution. Yeah.
Thank you very much. And the second part to that, just a number, and for that system, what would be the maximum fiber count MPO that could be used testing using that?
What do we mean by fiber count? Like the maximum?
Yeah,
like,
for that system, what would be the maximum MPO fiber count we could use? So I think, Tom, you mentioned 12 or 24 before. Would it be similar for that?
Yeah, so 12 is generically used for single mode, and we can go up to 24 for multi-mode.
That's more the maximum on the let's say the connection interface. The systems themselves, obviously, as you shift those connectors across, can handle up to thousands, right, of fibers.
Cool, awesome. Couple more I'm going to try and squeeze in. We are really pushing time, so I'll try and go through these. So just quick fire from an answer point of view. We can always follow up with more detailed answers if people need. So I'll run through this one. In a system for testing multiple fibers at once and having automated analysis of the testing, is there any method of preventing the installer or contractor from just testing the same 12 or 24 fibers over and over? Bit of a sneaky question, but yes.
It's a good one because it continues to happen out there, right? Fortunately, there is some people taking shortcuts in the game and getting one fiber, one cable tested perfectly and just trying to hit repeat. Charlene can probably comment on this more, but we do try to build in some smarts to the record as the results are being acquired and into the KPI engines to try and let's say sniff out some of those records that have very similar attributes in the records, right? So as you look through those records from a timestamp or from a loss event information, they're cut, copy, paste, right? So they start to have very similar attributes, which we try to mitigate in the analytics part of our tools. Charlene, maybe you can comment more.
Yeah, no, that's about it. That's what we do in the system. We look at different type of attributes and see if there's similarities or close similarities. Say.
Awesome, thank you. Right, we'll go for one more. For any others that are kind of queued up, then we can kind of capture some answers anyway, just conscious of time. So we'll go for this one from the last one, more of a skill set type question. So interested in your kind of thoughts. And then maybe I'll just do a quick closing comment from each. So should fiber optical engineering be a separate discipline in a network engineer's role? Thinking definitely of a VMO2 where I'm from. Currently a network engineer is a combination of RF and optical. So should that be a separate discipline or is multi-skilled feasible?
Viavi's view of the world that multi-skilled is very feasible. In fact, we design a lot of our systems and instruments so that they are multifunctional. They're combination tools, right? Whether it's a BERT test with an Otdr, a BERT test with optical, a BERT test with inspection of the connectors, or it's an RF test in the field. You know, some of our new RF test tools are ONA, optical network analyzer, our alignment tools, all are part of the same function. So we very much see the issue and the shortage in skill set out there. We very much see that we don't have the luxury of having widespread technicians covering very narrow disciplines. You know, some areas of the market call it a one tech approach, and we're very much of that philosophy. And we try to make all our test functions very simple, and we manage the tasks via very simplified apps so that when the technician comes down, whether they're doing an RF measurement, an optical measurement, it's managed in a job manager, and they just hit on that task and the tool automatically sets up and does the acquisition. Obviously, there's a physical connection to make to the element under test or to the network, but at the end, we try to simplify as much the setup so that take the setup headache away, take the number of steps they need to do away, and we're just going hit and task, do a measurement, hit a task, do a measurement. They may not know how to decipher all of the results of all of those measurements if they're from different disciplines, but we're definitely trying to knock down those barriers.
Awesome. That's a cool answer. Right, so I'm going to wrap up kind of questions there, but I am going to just a quick, very quick answer from each of you. We look back at the last 3 to 5 years at what you thought was each of your biggest advancements. Now, a quick prediction one. What technology, what advancement do you expect to see in the next 3 to 5 years that excites you most? One that we should watch out for. So just one from each of you, just a very quick, what should we look forward to?
Well, from my perspective, I don't see the need for more pathways slowing down. I mean, I think the fiber is diffusing into our world. In fact, I think it's becoming, you know, a fourth utility, and in many places, a fiber connection is becoming a requirement on new building. So that pathway is not going to slow down, and that means we need to find a way of creating ever more pathways. But I do think that there's going to that there will have to be a change in the ecosystem somewhere if we want to go even smaller in fiber. And so I don't expect to see that until we have real pain points and real problems that need to be solved, so that changing the ecosystem is a reasonable and viable thing to do.
So, thank you, Roshene. Tom, Charlene, to you, a prediction for each of you.
It's fiber, James. So surely it's endless possibilities, right? So the world is your oyster, right? No, look, we definitely see pathways and more pathways required. So we've talked a fair bit about that today. I think the next step will be, how can we get smarter using the pathways that I have, right? So when I've got all of these high fiber count pathways deployed, right, the possibilities or applications across it are endless. But I don't want to go and do overbuilds and redigs and have to do all of the cost of deploying more pathways and more pathways into the same area. So there'll be definitely a lot of exploration on how I can mux different services over the existing fiber. So you will see coming here in the near future, GPON. We already know XGS PON is here, 25 gig PON, and DWDM PON or WDM PON in the access. So all of the channels and services that we utilize across the existing high fiber count that we'll have deployed will be something to watch out for. Creates another element of complexity in terms of mapping, which is saved for another date, but definitely opens up new possibilities in lowering the cost in that in the access network.
Cheers, Tom.
What I think, of course, DWDM is going to be a big thing in the near future in the access. So more pathways means also more channels, for sure. One thing that I think will be significant in our instruments is bring more intelligence in there. Having the ability to simplify the user interface and also the interpretation of the test results. Something more reliable and less complex to analyze by the different technicians. So more intelligence will be in our device, I believe.
Awesome. Awesome. So any questions kind of not covered, what we'll do is we'll circulate and we can get some responses kind of direct back to those that have asked them anyway. So just conscious of timings, and we've ran fairly over. So we'll call it there. So just kind of to everyone that has attended and is still here, thank you very much. Hopefully that was beneficial or you took some value from that. If you have any questions kind of post, then by all means just feed them in. You potentially receive a feedback survey as well. So by all means, just drop some thoughts on there on how it went for you. Any final words from any of our expert speakers?
I'd just like to thank my fellow panelists and the SCTE for hosting us today. It was fantastic. Thank you very much.
Yeah, I echo that. Thank you very much. Thank you, James, for being such a good moderator. And thank you to Viavi for inviting me, because it's been a really stimulating conversation.
Awesome.
Cannot agree more. Thank you.
Thank you very much. So yes, final thanks. So thanks everyone. We'll be back sometime soon with the next one. But yeah, thank you very much and enjoy the rest of your days.
Thank you. Bye-bye.
Thank
Cheers all.
you.
Bye-bye.
Bye.